Welcome back, everybody. Today we're tackling lesson 11.4, and in 11.4 we're going to get into finding volumes. Okay, so we've done surface area. Here we're going to do volume, and hopefully what you see volume's a little bit easier. We're going to go back to looking at prisms and cylinders. Objective today to find the volume of prisms and cylinders. Okay, first off, what is volume? Pretty simple. It's the space a figure occupies. Okay, when I say space, I'm talking three-dimensional, not just on your sheet of paper, but how much 3D space does it take up in a room. Okay, so we're finding a three-dimensional measurement here today. And finding the volume of a prism is actually pretty simple. I'm going to say the volume of a prism is the product of the area of the base and the height of the prism. Okay, or we could say V equals B times H. Now notice B is a capital B as in the area. Okay, not just the dimension of the base, but the actual area of the whole thing. And the way you can think of this as working is find the area of the base and then multiply it by the height or stack it up the height times. That's going to give you your third dimension, your volume. All right, let's take a look at an example. So in problem 1, we're starting off with a rectangular prism. Okay, rectangular prism because the bases are rectangles here. And we just said a minute ago, the volume is equal to the area of the base times the height of the prism. Now the question for this one is which side is my base? Remember, with a rectangular prism, it doesn't matter. Okay, I can use the top and bottom as my bases, the right and left sides as bases, front and back as the bases. Okay, since it's shaded, let's say that this shaded side is my base. So to find its area, we'll just go 6 times 5. And then times the height. Well, the height's going to be my distance from base to base. Well, if my base is on my right and left side, this will just be times a 12 here. Okay, now with a rectangular prism, it really doesn't matter what order I multiply these in. Okay, 6 times 5 times 12, 12 times 5 times 6. Any order works. You can just think of it as length times height times width. Okay, either way we get 360. So we'll say 360 millimeters to the third power, because again, we're talking about a volume here for this one. Okay, in problem 2, let's show you how that same formula applies to other types of prisms. Okay, so in this example, we'll do some triangular prisms. Okay, triangular prisms because the bases, the parallel congruent sides, are triangles in this case. So we said V equals base times height, area of the base times height of the prism. Now we really didn't need that for the rectangular prism. This formula is going to come in handy as we get into the uglier shapes today, like we see here. All right, so starting off, area of the base, what we need to do is we need to figure out the area of the triangle on the front of this. Okay, so we need to start by finding that area. Now, area of a triangle is half times base of the triangle. Now, since this is at a right angle, I can say 35 is the base and 7 is the height of this triangle. Now, typo here, this is supposed to be millimeters there. Okay, so half times base times height, 7. That's going to give me this area, this face on the front. And then what we'll do is we'll multiply it by the height. We'll stack that area up 18 times, you can think of that as. Okay, so half times 35 times 7, that's going to give me my area of my base. And then times 18, that'll give me the entire volume. When I do that, I end up with a 2,205 millimeters squared, we could say. Okay, problem B is the same idea. I want you to take a minute, pause the video, see if you can work through problem B on your own, then hit play to check your answer. All right, let's get part B a shot. Let's see if I can squeeze it in around my face here. Volume equals area of the base times height of the prism. Okay, so V equals area of our, once again, triangular base. That'll be 1/2 times base of the triangle. We can say it's 22. Times height of the triangle, which is a 7 again. Okay, that'll give me the area of the base We'll then multiply that by the height of the prism, distance between the bases, so times 25. Whoa. Whoa. And when I multiply all that through, I end up with a 1925. We can say meters squared. Okay, so 1925 meters, whoops, to the third, not squared. Yuck, ugly problem. Okay, when it comes to finding the volume of a cylinder, we're really just going to do the same thing. Like we said in 2 lessons ago, that a cylinder is really just a circular prism. So we expect the volume formula to be the same, volume equals base times height, where in this case the base is the area of a circle. So in other words, we could say pi r squared times height. Okay, I like to remember as few formulas as possible, so I'm just going to use this one here, volume equals base times height. Okay, but again, that base is pi equals r squared. All right, so let's get problem 3 a shot here. What's the volume of the cylinder? Again, a minute ago we said volume equals base times height, area of the base times height of the cylinder. So in this case, our area of the base is just going to be the area of this circle on the front of it. Okay, area of a circle is pi times radius squared, so we'll say pi times 9 squared. That'll give me the area of the circular face, and then multiply that by 7, the height, the distance between the bases, and that'll stack that circular area up 7 times. Okay, now we can give this answer in terms of pi. If I go 9 squared times 7, that gives me a 567. So I could say 567 pi inches to the third. All right, or if I go 567 times pi, that's going to give me a 1781.3 inches to the third. Okay, either one of these will work. I guess just pay attention to what type of answer the question's asking for. I left this blank just to show you both, but test time, quiz time, we'll ask you for something specifically. All right, the last thing we're doing in this section is look at a few kind of advanced cases where we make some adjustments to our formulas here. Okay, so we'll just go through these one at a time. First one, find the volume of the composite figure. I'd say composite figure because it's not quite a cylinder, it's a cylinder with a chunk missing. Okay, now pretty simple approach we can take with this one. I know that volume's equal to base times height. Now the trick is though, is I'm not looking at the full cylinder. What am I looking at? It looks like I'm looking at 3/4 of it. Okay, this central angle on this sector would be 270 because I have the 90 here. So 270 over 360 just reduces to 3/4. So if I want 3/4 of the volume, I'm just going to multiply my volume formula by 3/4. Okay, so let's fill that in. So we'll say we're equal to, we'll save the 3/4 for a second here. 3/4 of area of the base, which area of this circle here, if we imagine having the whole thing, would be a 5 squared pi. Okay, pi r squared. All right, times height of the cylinder. So times 10. And then I can just plug this all in one shot here. In blue will give me the volume of the whole thing. Multiplying by 3/4 will take that quarter out. So I can just go on the calculator, 3 divided by 4 times 5 squared times pi times 10. We'll just round this, won't leave it in terms of pi. And that's going to give me a 589.0, I guess we could say, feet to the third. All right, so that's one way we can make adjustments to our simple formulas just by dividing a chunk out if we know there's a fraction of it we're missing. Part B, we've got another composite figure we want to find the volume for. And this one's a little simpler. It looks like this one's just 2 prisms stacked on top of each other. Okay, we've got a larger one on the bottom, a smaller one on top. Okay, so what I'm going to do is I'm just going to find these volumes separately and then add them together to finish it up. Okay, so we'll start off with our V, and I'll say V sub L for volume of the large. Okay, volume of a prism, just area of the base times the height. Okay, for the base, we can say we have 18 times 8, and then height would be 12. Okay, and really we just need to find the 3 dimensions and multiply them together. Okay, 18 times 8 times 12 is going to be a 1728. Okay, the top one's going to be a little trickier. We'll say V sub S for volume of the small prism. Okay, as far as its 3 dimensions go, we've got a 6, we've got a 3, and then what do we need? We need kind of the width between the two of those. We need this dimension, which is just the same as this 8 right here. These 3 chunks are all going to match up and be 8. So for this one, we can just say 6 times 3 times 8. All right, which will give us a 144 for that volume. And once I have those two parts, we can say V total is just equal to 1728 plus 144, which will give us a 1872 centimeters. I keep doing it, not squared, to the third. All right, so that's another way we can find volumes of composite figures, just by finding the figures separately and then adding them together. One is just 2 shapes stacked on top of each other. All right, here's the last composite figure we're going to look at for today. As far as what we're looking at, let's picture this as a prism with a cylinder taken out of the middle, basically a hole drilled through the middle. Okay, so that's obviously going to subtract from our volume. If you think of putting a shape like this into a bathtub, it's going to raise the tub less if it has that hole drilled out as if it didn't. Okay, so prism with a hole drilled out. So this one we're going to approach similar to our last one. We're going to say the volume is equal to the prism, the larger shape, this time minus the cylinder. And we'll just find those two parts separately. Okay, prism, we've got our 3 dimensions, 18 times 10 times 8. I suppose we can multiply those out right away here. When I do that, I get 1,440. Then we want to subtract the cylinder. And for the cylinder, let's take a look at what we have. We need area of the base times height of the cylinder. Now the base is going to be this little circle here. And let's say it's giving us, it's a little tough to see, let's say that that's the diameter of 4. So in other words, the radius is 2. Okay, so we'll go area of the base, 2 squared pi. All right, times height of the cylinder, which is going to be distance from circle to circle. In other words, this 18 here again. All right, I'm going to multiply that out, and I'm going to say this one doesn't make sense to leave in terms of pi, just because I'm combining something without a pi with a pi, so we'll multiply things together. And that gives me a 226.2. All right, so for a total volume, we've got the larger prism of 1440. We're taking out the cylinder through the middle, the 226.2. When I subtract the two of those, I get a 1,213.8 inches to the third. All right, that's it for section 11.4, volumes of prisms and cylinders. As usual, make sure you get your practice in, give the homework a try, and let us know if you're getting stuck. Let us know if you need any help.